Now, let us see reduction of ER diagrams to tables when you have relationships. How to convert ER into tables when you have relationships. Okay, now look here. You have employee works in a department. So such a case, it can happen in your ER diagram. You have employee, where you very well have an employee number as the primary key. Employee name, salary, you will be having many more records. Works in the department. Department ID, again, you very well know that this is the primary key. You have department name, you do have many more things. And you do have a relationship set, which means, you know, your relationship, it can have an attribute. Let's say since. Okay, now imagine you have such a ER diagram. How do you denote it? So this is how the table will be. You will have one table, the first table, which is employee, and it will have all your employee details, employee number, employee name, salary, and so on, where employee number is your primary key. You will have a second table, which is the department, where you will have all those details over there. Department ID, department name, and so on, where department ID is the primary. So, you have taken care of this entity, you have even taken care of this entity. But you have something more important to take care of. Okay, so to take care of this attribute and this relationship, I always told you earlier, imagine you have a relationship, you should be taking care of the relationship. You should be taking proper care of your relationship when you reduce the ER to a table. So this relationship should be taken care of. So what I can do is, I can create a new table. Okay, you can have any name for that. Let's say I have a table called works or works in whatever. I will have a third table where I will be having both the primary keys of my related entities, which means I will have employee number, comma, department ID, comma, this is the primary key over here, this is the primary key over here. Have both those primary keys in your table as a foreign key. Okay, when it comes to another table, it will obviously be a foreign key. I'm just denoting it with a circle to make you know that it is a foreign key. This is a foreign key. Why is it a foreign key? It is a foreign key because it is the primary key of another table. Department ID, that is also a foreign key. Comma, you need to take care of this particular attribute, since. Okay, since it will be a year, like let's say 1945 or whatever. You will even have this attribute called since. And as I always told you earlier, tables, they cannot exist without a primary key. So the primary key will be a combination of all these together. Of course, you will be calling it a composite key. So when you have a relationship set, which means, when your relationship gives birth to an attribute, this will be how you denote your tables. Table number 1 will be a normal table with all the entities. Table number 2 will be a second normal table with all the entities. Both will have primary keys. You will have a third new table, which will take the primary keys of both the connecting entities plus the new attribute, all of them together will be the primary. A will be a normal table with A1 as the primary key. B will be a normal table with B1 as the primary key. You will have to construct a new table R, which will have A1, which will even have B1. Why? Because A1 is the primary key over here. B1 is the primary key over here. You will even have your extra attribute, the relationship set attribute. All these together, they will be your composite primary key, out of which A1 is a foreign key, B1 is also a foreign key. Now, let us see how you construct tables when you have binary relationships. As you all know, you do have many kinds of relationships. It can be 1:1, it can be 1:n, it can be n:1, it can even be m:n. These are the various kinds of relationships which we have. So we will see case by case. Case number 1. When you have an m:n relationship, what should you do? Now always keep in mind, as I always tell you, whenever you have a relationship, the relationship should be taken care of. It should either go to your A part or it should go to your B part, or you will be making a new table for R. So the easiest is if you have an m:n relationship. The first table will be your table A, which has A1 and A2, where A1 is the primary. That is easy. You will have a second table called B, where you have B1 and B2. B1 is the primary. Now, you will have a third table. You can give any name for the table. It is denoted with the name R over here. Because it is an m:n relationship, you will have a new table R, which has nothing else. A1, B1. The primary keys of both the other tables, they together will make your composite key. As you can understand, here A1 is the foreign key, B1 is also the foreign key. This is a composite primary key. So, if you have such a relationship, this is how your tables will be m:n. This is case number 2. Case number 2, when you have a 1:n relationship. Look here, it is a 1:n relationship. As I told you earlier, you should never forget your relationship. You should take care of it. Now, see, if you have a 1:n or an n:1, be it whichever, your relationship will always be focused on the n part. The relationship will move to the n part. Be it a 1:n or an n:1, the relationship will be always moving towards the n part. So that is something which you always need to have in mind. Now, in this particular case, if you look here, it is a 1:n. So, you know, the relationship will be moving to the n part, which is the B. So, let's have tables. You will have one table, table number 1, which is A. A will be A1, A2, and you very well know that A1 is the primary key. Your second table is a table called B, because you know my relationship is moving to the B part, I will denote it with BR. But when you name it, if this is course, you can simply have the table name as course, no issues. I just have it over here BR to show that the relationship is moving towards the B part. That is why I denote it with BR. Now, in your second table, you will have B1, which is the primary key. You will even have B2, which is a normal key. And because the relationship moved to B, when it was moving, it even pulled the primary key of A, which means you will even have A1 over here, where A1 is a foreign key. Okay, so this is how you denote a 1:n relationship. We'll go on to case number 3, where it is an M:1 relationship. Where it is an M:1 relationship. Very well, you know that you should take care of R. R will have a tendency to move to the portion which has M or N or whatever. So, let us write our tables for the M:1. Okay. So, you'll have only 2 tables. The first table, or I'll write my A table itself first. A, I will have A1, A2, where A1 is the primary key. You know that the relationship, it tended to go to A. So, I named it like AR, A1, A2, because, it moved towards A. It pulled something from B. It can pull only the primary key of B, B1, which now here acts as a foreign key. My poor B table, I just have it as B1, B2, because, it has a cardinality of only 1. It is as it is. Now we have a 4th case for relationships. When it is a 1:1 relationship. What will you do if it is a 1:1 relationship? Actually, 1:1 relationship, there are 2 ways of doing it. Both has its own advantages and disadvantages. Anyway, we will see both. You can follow whichever you are comfortable. Now, the method 1 is anyway, you don't have your relationship moving to any side over here because both are 1. As you know, relationships, they tend to move only if it is a M, something more than 1. So here, one way in which you can do it is, you will have A with A1, A2. You will even have B with B1, B2. You can imagine R is moving to A. You can imagine R is moving to A. B1 will come over here. This is one way of doing it. Another way of doing it is A1, A2. Here it will be B1, B2. You can imagine, R is moving towards the B part. If R is moving towards the B part, you will have the A portion coming together with it. You will have the primary key of A coming towards it. A1, this will be the primary key over here, this will be the primary key over here, this will be the foreign key. So these are the 2 ways in which you can do if it is a 1:1 relationship. What will you do when you have total participation? I hope you remember what is meant by total participation. It is denoted by 2 lines, which means, every entity in B will have a corresponding entity in A. So this is how your diagram will look like. A, B, and imagine it is a 1:n relationship. As you know, it is a 1:n relationship. A will simply be A1, A2. B, R will focus on B because here you have the N. So you will have BR, B1, B2. A1 is pulled from there, the foreign key. These are your primary keys. This will be your table design. But you need to take care of this you need to take care of this total participation, which means, every entity in B should have a corresponding entity in A. Every entity in B should have a corresponding entity in A, which means, it is a very simple logic. You should always see that, A1 is never null. A1 should never be null. If A1 is never null, A1 has a value, you can include it over here, which means, total participation is guaranteed. So, if it is total participation on one side, you need not worry at all. Either it be your 1:1 or your 1:n or your n:1 or your m:n. Follow the same logic. Follow the same logic. Only thing is the foreign key, when you think about the foreign key, its corresponding value in the parent table should not be null. This is for case number 1, when you have total participation on one side. It is a bit different when you have total participation from both sides. Now, when you have total participation from both sides, it means, A should have a corresponding entry in B. B should also have a corresponding entry in A. It is to and fro, the same kind of rule happens. Now, if you have such a case where you have total participation from both sides, you will just have a single table combining all these together. You will have A1, A2, B1, B2, where both these together, you will have a composite primary key. Now, if it is total participation from both sides, this is a unique case where you will just have a single table taking care of all the attributes to. Okay, so this is how it comes. I'll explain once again. I'll delete up the whole thing and then. The first table, as you all know, will be a table, the cardinalities n1, 1, n. Okay, you will have a table called L. It is a 1:n relationship, which means, the relationship will move on to the L portion. So I'll just denote my table with LR1. I'll have my usual attributes L1, L2, L3, where L1 is the primary key. Because the relationship moved from M to L, it will pull the primary key of M, which will now be the foreign key in my L table. Then I have my second table, which is M. It is the one portion. So I need not bother about that. I just have M1, M2, M3, where M1 is the primary. I'll have my third table, which is my N table. If you look over here, 1:n, which means, my relationship tends to move to my N table. I will be having my normal entities, N1, N2, N3, where N1 is the primary key. And, because it R2 moved from M, it will be pulling the primary key of M. M1 will now be the foreign key over here. Okay, so R2 is moving to A, which means, R2 is pulling the primary key of C. And what is the primary key of C? The primary key of C is C1. Okay, so I'll even have C1 over here. That is a foreign key. Yeah. And so that's it, my tables. Take this down and do it as homework for Thursday.